Hello, everyone. Welcome to our fourth FHIR Foundational Series session hosted by Digital Square. This session will focus on FHIR implementation guides. For those of you who are new to Digital Square, we work with innovators, governments, and donors to support country digital health programs. And one of the ways we do that is we support adaptable, interoperable tools that are designed to work together seamlessly. We do that through many different ways, but also through webinars like this. But before we get started, a few house rules. The session is recorded and will be posted on our wiki a little later this week. So we do ask that you mute yourself so we can hear the speaker. If you have a question, a comment, please go ahead and put it in chat or put it in this Google Doc, and we'll make sure that we capture it and kind of go through the questions as quickly as possible. You'll see the Google Doc also has recordings or links to the recordings for other webinars in this series. We will have about 5 minutes into the hour of this presentation for questions and answers, and then 10 minutes at the end. So please, again, keep throwing those questions in chat, and we promise to get through as much as possible. As we are kind of getting through the process of setting up, I will ask that if you do not have GitHub client on your desktop, we do recommend having it if you want to participate and play along as we do this session. So please go ahead and download it as we wait. And with that, I will introduce our speaker, Jose, who has led most of our previous FHIR sessions. So if you don't know Jose already, he is a data management standards and interoperability consultant who has worked in the sector for over 20 years. Jose developed Orbis and impacts healthcare products. And in addition, he has been involved in integration projects, such as the development of integration and data analytics systems in Europe and Latin America, integrations in large hospital groups in Paris, and has contributed to national integration frameworks in Belgium. He's the co-chair of the IHE Pharmacy, as well as an avid supporter and contributor to FHIR. Since 2007, Jose has been contributing to global healthcare standards like HL7, IHE, and ISO. And he's also facilitated the launch of the HL7 and IHE work groups in Brazil, Portugal, and Belgium. All right, Jose, over to you.
Thank you, Brenda. Hi, everyone. Yeah, let's just get started. Thank you for joining this session. We have gone through a few sessions about the basics of FHIR and a bit of profiling FHIR. So we would start today with recapping the basics from those presentations. So I would start exactly there. Allow me to share my screen. So as I presume you can see my screen, this is the agenda. So we have gone through the house rules. We will just do a quick recap of the FHIR basics and profiling. So those were the two first sessions that we have. They are recorded, so you can always go back to look at more content. And another recap on terminology. So that was the session last month. And today we are going to see what are implementation guides, what is it, when to use it, how do you make one, and how do you use one. We are going to see what's behind the implementation guide. So what are the FHIR artifacts that compose an implementation guide? We'll go a bit through the tools and process considerations. So what you need to do to set up one implementation guide on your own. And the second hour of the session will be that we make a practical example. So we just implement one. So we're just going to make an implementation guide ourselves. So I'm going to make one as we go through the session, explaining what's behind it, and hopefully you can follow. You can play along. You can follow the example by doing it yourself. The tools that we mentioned, they are sufficient for you to either do it offline if you wanted that, if you did the whole setup, or if you have at least the GitHub account and GitHub client that you can do this, but just by copying the files as we will have them. And with that process that we set up for you, you will end this session, if you want, with your own implementation guide. We chose one simple topic, but of course you can make your own implementation guide in the future for whatever topic that you want. With that in mind, a couple of disclaimers. So throughout the session, we mentioned FHIR HL7. This does not mean that this course is endorsed or recommended by HL7. This is not an official HL7 training. It's more a community gathering and a quick jump start for people that want to have some initial exposure to these topics, in this case to the implementation guides. All of this, what we are using in terms of tooling and in terms of materials, this is freely available, and we share this presentation under a Creative Commons attribution license, which means you can share as much as you want if credits are given. So moving on into what we are going to do, so just first the recalling the basics of FHIR and profiling. We will see that this is about the technical and computable artifacts. So it's something that we do technically, and that will produce the outcome that we need. So in this case, profiles and extensions and vocabulary resources, those are technical artifacts. We will look at some of them. We'll look at the resources, data structures that we need to play with, and the data elements that are inside those data structures. We will look now into terminologies as well. And then we need to understand what's the FHIR implementation guide in terms of what we mentioned before, concepts, tools, and practices, and we'll develop a simple one. It's going to be a really simple one, but I also wanted to expose some more advanced things that you might want to use. So, as I said, we will use open source tools. GitHub account is required if you want to do online, if you want to follow this online. So if you want to play with your own implementation guide and make one online, you must have a GitHub account. It's free, so it's highly recommended. You will need to edit some files, so it's also recommended that you do this on your computer and then upload to GitHub. So for this, you need a GitHub desktop. And if you did go through this exercise of installing Java, if you didn't have it, and Jekyll and Sushi, then you should have all the tools that you need. I'm going to use those tools locally just to show you how they work. If you want to do this, if you want to make your own implementation guides, you can, and you use these tools. If you just want to see today how it works, you can just use the online toolkit that we have prepared and we'll present to you. With this in mind, I would like to have a quick check on the familiarity of people within implementation guides. So is it possible, does it make sense, and can I please ask that anyone that has not seen an implementation guide, that they just put a note on the chat, just because if everyone has seen an implementation guide, if they know what it is, then we can save some time and we can spend more time on the practical stuff. But if not, then we just spend a couple of minutes, 1 or 2 minutes, just with the more basic information. Is there anyone in the audience that has not seen a FHIR implementation guide yet? I'll continue anyway, but I'm looking forward to some answers. So the FHIR foundations. This was the first session that we have. On the same site, on the same website where this webinar is announced, you have the recordings for those. The highlights of this session, of the first session. So FHIR is a technical standard for data exchange, and the unit of data exchange, so the atomic unit of data exchange is the FHIR resource. FHIR resources, they are things like patient, medication, device. Those represent the agreed data sets for exchange. So if you want to exchange data about a patient, you put this in this data object. And if you want to exchange data about a device, you put this in another data object. Those are the minimum common data set, let's say. They can always be constrained and extended, which is exactly what we are going to do today. And in FHIR terminologies, we will see more details later. We can define our own value sets, and we can define code systems, etc. So if this is a short representation of what is behind the FHIR ecosystem, we are going to mostly focus on the resources, the elements, and the data types behind those, and the value sets that bind those data elements and the code systems. We'll recap a bit of this part here. The rest is the other side, the other many aspects of FHIR. We are not going into those details with those things, but we are just going to make some examples of profiling and even one example of a logical model. So what is profiling FHIR? First thing, what is profiling FHIR? When we talk about profiling FHIR, We have, in FHIR, we talk about taking something from a base definition. So taking the patient, the FHIR base standard patient resource, and doing something with it that meets our purposes. So some examples, the patient, my patient could be a profile on patient or a profile on US core patient. So I can take something that exists, whether it's in the core base standard or in any other specification, and I can make my specifications. And from this, I can make other specifications. So this is a layered thing, as we'll see next. But we can make medication prescription lines if we want to make a profile on medication request, if we give it that name. Or I can say, I want to define my patient, but my patient is going to be for US, and I don't want to redo all the basics that the US core patient profile has already defined. So I just define my own things. So FHIR profiling is taking a base and adding extensions, constraints, different bindings, exactly what we are going to do today. And that's the exercise of profiling. It's important to know that everything in FHIR is defined with resources, except the narrative text. But when we want to define resources, we use a FHIR resource called structure definition. So if I want to define my patient, I'm going to define a structure definition that defines the data structure, which is my patient. And that structure definition contains element definitions, which defines the individual data elements. And of course, the value sets and code systems, they define the terminologies. All of this is in the profiling page of the FHIR specification. So when we look at profiling FHIR, the most common aspect of this is profiling data structures. As I was just giving the example of the US core, first thing is to select the right thing to constrain, the right profile to constrain. We can profile the out-of-the-box FHIR specification for patient, or if I have a national patient profile that already has the national extensions and the national constraints, I don't need to redefine that. I can just profile that one. So I can make an additional specification on top of an existing specification. How this is done is we take that resource as base, we define and redefine some of the data elements by adding constraints and also adding extensions. Adding constraints means we can change the name, or not the name, but the short description of the element. And we can change the cardinality. Within some boundaries, we can say, I don't want this element to be present, or I want this element to be mandatory. So there is, those are the basic things that we will do for profiling. When we talk about extensions, we are talking about one thing, which is taking the extension resource. We will see it next, and we add constraints to its elements. It's better that we see it in practice, but it's all part of taking one structure, adding constraints, adding extensions, and update the use of terminologies there. So, because of this possibility to have specifications built on top of specifications, there is one very important aspect of FHIR profiling. We can make it in layers. If I have, as I said, if I have my national specification, I don't want to bother redefining those specifications on top of the basic FHIR resources or the core FHIR resources, because I don't need to, and because if something changes on my national specifications, I don't want to be forced to go and catch up with those specifications. So I can use those specifications as my base. So this means that we can make a structured or a layered approach like this one that we are seeing here, which is we have FHIR base specifications, which define the resources and some extensions. We have standard constraints, so working groups like IHE, HL7 working groups, OpenHIE, and other institutions can define standard behavior and say, or the WHO. So lots of organizations can say these are topic-specific specifications, topic-specific value sets. We can accept that there will be lots of global specifications, and then we have national guidance on top of this, or we can have national guidance on top of the FHIR-based specification. We can choose. National guidance is, for example, vocabularies, mandatory data, some specific data elements that are required. For example, the national patient ID or national person ID will be different country by country, so that's expectable in national guidance implementation guide. whereas a standards organization, for example, IHE, can say this is how you provide privacy, or how you provide security, or how you provide patient identity matching, or how you provide medication workflows. These are global things from which we build the national specifications, or onto which we attach national specifications. And on top of this, if we want, and it's always a good idea, we can do project specifications. We can say, I'm in this country using this IHE profile, and which is based on the FHIR specification, but I still want to define my own specifications in a computable way, in a standard way, because I want my business partners to look at this and see what I mean, what are my constraints on the data. Instead of reading a Word document, then they can read the implementation guide. So this is the layered approach that is I would highly recommend it, to use it as much as possible. It saves you work and saves your readers also work. So a bit into the details of the specification. What we have is the following. We have every element that we have in FHIR is defined through an element definition. So we have a couple of characteristics. We have the let me just show a few here. We have the short name of the data element, the definition of the data element. We have the minimum and maximum cardinality of that element. So if it's mandatory or not is defined here. We have fixed values. We have pattern values. We have bindings. We have all of these definitions of one single data element. They are in one FHIR resource. So this is how it is defined internally in FHIR. And the one other resource that puts all of this together is the structure definition. So without going again into the detail, structure definition defines a resource or a profile, which has lots of metadata, who's the publisher, what's the version, what's the status, etc. And then the fun part is here. We see that there's a snapshot of the differential, and differential basically says, I have these elements, so several elements, and this is how these elements that I have here, they differ from the base that I defined. So if I'm taking a patient resource and I'm saying that gender is mandatory, for example, what I'm doing is making a small differential between the base patient profile, the base patient resource, and my patient resource. And I'm saying that that patient resource, the differential is that this element has a cardinality difference. So we have this as a kind of a glue. We don't have to look into all the details here. The juicy part is the one that we are going to have some practical examples about. The structure definition can also be used to define logical models. We are going to have one implementation today of a logical model. This is part of a recommendation, so we were thinking, why not to put it in there? And it's part of the process. When you're defining specifications, we'll get to the process considerations a bit later. But when we do the specifications, it's important that we have a very good communication with our stakeholders. So they will provide requirements. They will say, this is the data that we need. We need patient identifier to be mandatory. And then you say, is it mandatory one or mandatory many? Is it any identifier, or does the national identifier need to be there? These things, they get quickly very complex in FHIR, because we're talking about slicing and extensions. That can quickly get too complicated, not for us, but for stakeholders that don't breathe FHIR. And in that case, it is practical to use things like logical models. You have an abstract representation of a data structure. You say, this is the data that we are going to implement. And once you have an agreement on that functional definition of the data, it's much easier to go to get their agreement, and they say, yeah, I agree, this is mandatory. There's one thing missing, or this tree should be different. Once you have that, then the technical mapping, so the technical profiling on FHIR, becomes really an implementation work. And in my experience, it saves quite some headaches to do it in this way, to have people more engaged, or to have more frequent engagement with the people in their own language. The other thing that is important to recap, so the last thing that's important to recap on the basics of profiling FHIR is the extensions. There's an extension element. I mentioned before extension resource. That's not the case. It's an extension data element. And the extension data element has, is a special element in FHIR that we can use basically everywhere. So most everywhere in FHIR. So everywhere that we actually will look at, except for some internal things in FHIR, all of those things that we are going to see today, they can be extended. So anywhere in FHIR, in a resource, in an element, or even in a data type, we can place an extension. So if I want to have an extension on a data type string, I could do that. If I want to have an extension on a patient.name, I can do that. And if I want to have an extension on the patient resource, I can also do that. So we can define extensions pretty much everywhere. And the good thing that we can have is that we can look at is and we will definitely use this today, is there are already many extensions out there. So we can define our own extensions. There's a process for that, and we will use a part of it today. But HL7 has already provided what they call standard extensions. And standard extensions means this data element is not really part of the most common uses of data exchange as we see it now. But if you want to do this, you should do it in this way. You still place an extension, but at least it's a common extension that if you use that extension, and if your neighboring country uses the same extension, and if the other project from another company uses the same extension, then you're better off in terms of interoperability. So you can always define your own things, but it's quite good to rely on standard extensions. Extensions are a normal thing in FHIR, and yeah, so as much as possible to reuse what's out there is always a good idea. I see one question from Alvin in the chat box. If it's okay, I would rather wrap up the terminologies part and then do a bit of profiling of the implementation guides, and then we would go to that. I hope that's okay, Alvin. And if you could message us, okay. Yeah, sorry, the question says question for later. I'll read it through. So terminologies. For those of you who were not in the session that we had 1 month ago, please go through it. I think it's worth it. Rob was explaining quite well the basics and the detailed concepts of terminologies. For us, the things that we care about today is just a couple of highlights. In FHIR, when we have an element, has a certain data type, and there are 3 data types that can be coded. Those are code, coding, and codable concept, and they work pretty much like what I hope the picture represents. When you have a code, it's just the code. You just put the code. You just put really 1, 2, 3 or status or active. That's the code. The meaning and the system of coding are implied by the element. So if you put active in a code that's for a FHIR resource status, then it's the status of the resource. If you put active on another thing, for example, what's the patient's lifestyle? Is it active or has sedentary lifestyle? That's completely different, but that's in a different data element. So the code has a meaning and the coding system that are implied by the element itself. So it's more used in the core aspects of the FHIR specification, like bundle type, patient.gender. Those are things that we just need a code. We don't need to explain much about that code because everyone will see the same thing and that they have to use that code anyway. So that's it. So the coding element is adds a bit more on that. So if you want to add a coding a code that's not necessarily implied by the system, by the element that you are using, you can add, if you want to mention a code, you have to say, what is this code about? Okay, this code is about lifestyle, or it's about technical status. Those you need to distinguish those. So we have a system, we had a version. So what version of the code system are we using? Are we using the codes? Let me use the simple example of countries. The code. What is the code? I think, yeah, what's the code GE meaning? If I'm making my own codes, maybe GE means Germany, maybe GE means Georgia. I don't know. So it depends on the code system that I'm using. So the coding data type adds those additional things that you need to do to know when you want to use those codes, and you also add a display so that when you use a code, you can also share with the receiving party what is the data, what's the textual display of that code. And you can add one flag, which is the user selected, which says this is the code. This code was user selected. It was not something that the machine automatically converted. It is richer, but it's not as rich that it deserves to be very commonly used. So the most commonly used is a codable concept, which has several codings and a text. For example, if you have one concept that you want to convey, for example, COVID positive status, you can do this. I think you can do this in SNOMED and in LOINC and in ICD. You can do this in several coding systems. So just one coding would not be sufficient, but you can represent that same thing in several codings. So you can have one coding for, this is the code for SNOMED, this is the code for LOINC, and this is the code for ICD. You can put those all together, and you can even add one text. The text is even useful when you don't have a code for that yet, and you say this is not coded, this is whatever, an unknown disease or something that you want to put there. In that case, if you don't have a code, you can at least have text. So these are the data elements. We will focus on the codable concept. That's our default approach, but that's the elements that we use. Just to see how the whole thing fits together. When we have the element definition that we were just discussing before, that is because we want to use it. So when we use in an instance, if I want to define patient 1, so if I want to put myself or my own demographics data in a patient resource, I'm creating an instance of a resource, and in there I will have some data. That data has to conform with FHIR, so it has to conform with the element definitions that I defined. So the element definitions, that is where we say, in every instance of this resource, this element is bound by a value set. And the value set is a collection of codes. And the code system is a set of codes. Let me walk through the difference, because that's the most important thing. The difference between code system and value set, as a recap for those, or as a recap and just as a short note for those who were not in the session last month. In FHIR, we have code system, which define the codes, so define symbols with specific meanings, LOINC, SNOMED, ICD-10. Those are code systems. And value sets define subsets of that to use in a particular context. For example, the list of countries. We have ISO 3166, if I'm not mistaken, as a code system. But within that, we might want to use just European country codes, because that's where we intend to use it. Or maybe we just want to use certain regions in Europe. For example, for GDPR, there's the European Economical Area, which includes a different subset of countries. That's a different value set based on the same code system. This is especially required for big code systems like LOINC and SNOMED. We cannot say this data element is bound by SNOMED, because then it can mean everything. It can mean an observation, an entity, or also an observable entity, a disease, I don't know which types of concept. It can mean too many things, and then we have many elements, many values there. So we say we want to have SNOMED CT codes, but only under, for example, fracture codes, and then we can make that value set as a subset of SNOMED. So for our purpose of recording, what is this fracture? So why is the patient going to the orthopedist? Then we have as a value set only the things that are relevant to fracture codes. So this is the and that's the key difference between the value set and the code system. The terminology binding works as I mentioned before. So an element definition, when we define in a profile one data element, we can say, so in most cases, or in many cases, we can say this element will now be bound by my value set, whatever value set that I want, and that's related to a code system. And the way to do that can also have different levels of strength. I will explain. If you have a code that it really must be from those codes, no other codes are allowed, it's different from saying you can use this code in this element, or you can use any other code that you want. So those two statements are completely different, and we have 4 levels of that in FHIR. So the most liberal one is we have an example, we call it an example binding, which means we say these codes are just here for your information, for example, and you can use these codes or any other code. There is no recommendation on our side except to give you an example. The preferred binding is when we say you should use these codes if you have another reason, for example, in your countries, or if you have another preference, or if you want to use SNOMED, or if you don't want to use SNOMED terminologies, you can do it as well. It's just deviating a bit, but it's not something that is blocking compliance. The other one is extensible, and this is a bit more strict, and in the sense that if you have a code for what you mean in this value set, you must use it. So, for example, if you have a code for allergies, and if you say I want to use I have a code for peanut allergy, and if this value set it has an extensible binding, and if we say that this is an extensible binding to this SNOMED code, SNOMED value set, if you do that, then you cannot use the LOINC code for peanut allergy or another code for peanut allergy. If we say that this is an extensible binding, you can extend it, but you cannot change what's already there. If what is already there has peanut, and if we say peanut is this SNOMED code, then you can only use that code for peanut. You cannot use the other ones. And the required is the more strict of them all. You cannot use anything else. You just have to use one of those specified codes. If you have any other code, you cannot use this data element at all. So okay, so looking at the some short considerations when profiling. We will see this. We'll see this in practice later, but so allow me just to keep it short like this. Use examples. So whenever you validate with your stakeholders, try to bring examples, both in the discussions and in the implementation guide. Have examples, because examples are very important to see, is this what you meant? Yes, no, I forgot one data element, good, then let's fix it. This is very important. Use logical models to discuss with stakeholders, as I mentioned before, and very important, I would say, very recommended from my side is set up a way of working. So if you want to validate often, if you want to have discussions with your stakeholders, try to set up working groups, recurring calls, try to have review meetings. It becomes a way of working, so it's not just a couple of emails going back and forth. The other thing that's related also to, in terms of recommendations, but related to what we were just discussing now, is choose your strength. When you do profiling, if you make something mandatory, it might seem better because my data will be cleaner, but if you do that, if someone does not have the data and if it's mandatory, then the message will be rejected and then you have less data than you should. So try to find a balance between making something mandatory or making a terminology binding very strict, because if you do that, you are just going to make sure that you reject, that you don't even get to see the data that was non-compliant, and maybe there's a reason for that data to be non-compliant. It's just because your specification might be too strict. So try to balance those two things. And now off to the implementation guides. I didn't see anyone saying that they haven't seen an implementation guide. So very briefly, the implementation guide. A FHIR implementation guide is something that the FHIR community uses a lot to transport the functional and technical requirements into technical specifications. So this is the way to make and publish FHIR specifications, is the implementation guide. The implementation guides and the tooling that comes with it, they create a web specification, so a couple of web pages, and that set of web pages contains what the implementers are typically expecting to see: the data specifications, some narrative text, some examples, some additional guidance. Those are the things that we expect to see as implementers in an implementation guide. So that's what the implementation guide presents to them. And the purpose of this is just a couple of highlights. It's supposed to take the requirements and define technical specifications. FHIR is new and FHIR is very much technology oriented, but we should keep in mind that it's not the other way around. So it's not the technical specifications that are going to define the requirements. Of course, the technical specifications that exist out there, they should be a good basis for us not to reinvent things and to use best practices, but we should keep in mind that the process should be, as much as possible, listen to your stakeholders, see what they want, validate very often, but it's not just a technical specification. There's a big component of finding the functionality that is really required. And the purpose is also important. So you should be clear, what do we want to do? Am I defining my own system so I can do whatever I want? Or am I defining my national specifications for this? So I would like to give some word of caution, like define your level of criticality or your level of specificity, if I can say that word. If you're on a lower level, you should be a bit more flexible. If you have something that is more for your system, you should be for a higher level. You should be you can be more specific or less specific depending on where you are in that layered approach. So then let's look at the implementation guides then. So this is one example of an implementation guide. Actually, just for sake of making it quicker, let me show a couple of implementation guides. So this implementation guide is a web published structure. This is the one that we are going to end up today here, and I'm just going to bring one up. This is an online publication. It has lots of pages that are generated. So the implementation guide tooling, as I said, and it's a set of or it produces this set of pages. This is what we have, and so what we produce. And there is lots of things. So there's a home page. We can add text as we want. So we can add narrative text about the methodology, the references, some use case overviews. And for us to always navigate in the same way, there is a couple of key points, like the artifact index. This is the page that contains the profiles or the logical models or the other things that we need. There is a consistency in navigation, and this is one of the key points in the implementation guide. So when you produce something, you don't have to worry too much. It's going to be done automatically for you, but it's important that you see what an implementation guide does and how it navigates. So for those of you who have seen it already, just a couple of examples. Implementation guide can produce pages, can produce diagrams, we can produce more types of diagrams. Sorry, this is just a few examples that I had at hand, or just narrative text. And they can all look a bit different on the top and on the bottom, but everything has the same, oops, this is a broken link. That's not what I want. And there is lots of content here. These are the artifacts that are defining this one. So there's some consistency to the navigation here. So going back to the presentation. The FHIR artifacts that we use, so let me just quickly go through this. In FHIR implementation guides, the implementation guide is itself a FHIR resource. It has lots of things, lots of data. The implementation guide itself has a core which has who is publishing it, what's the URL, what's the title, etc. Those things will be visible when you publish. The key part is that the implementation guide defines or has a definition. So we say these are the things that define my implementation guide, and that has, for our purpose, the best is to have a page or pages and resources. So we can put pages in an implementation guide, and we can put resources in an implementation guide. We can put other stuff as well, but we can define other stuff as well, but those are the key things. What we are going to do today is indeed to add one page and a couple of resources to define one implementation guide that we are going to create. The rest is a bit more technical infrastructure. We can always chat about those in the questions and answers. We can do this in the chat.fhir.org. That's a very good place to ask questions. And yeah, the implementation guide is our, let's say, our holder for all of the resources and artifacts that we are going to produce. And in fact, having an implementation guide, when creating an implementation guide, just means to create a set of files that provide that content. So when we say I'm going to create an implementation guide, we are going to create one implementation guide resource and all those other resources and pages that bring body to the implementation guide. That's what we are doing, which is why we use version control. So we will have several changes to the files that we are using. And when we do that, it's always a good idea to keep version control, so that we say, I'm going to change this. Let me see why this is not working anymore. Let me see what has changed since I worked on this yesterday, etc. So these artifacts, they follow a standard structure, which I'm going to share now. The FHIR artifacts, so we call it artifacts, so those are the technical files that we provide to the implementation guide. Those can be FHIR resources in the FHIR standard formats, JSON, XML, or Turtle. And those can be profiles or logical models or value sets or examples or code systems or anything, and they all have a place. So if you want to put examples, so this picture here represents a folder structure. So if I want to save my resources or my models, I always have a place for that. So I can put my examples in the examples folder, or my models in the models folder, or my profiles in the profiles folder. To be honest, the tooling doesn't really care. You can put a model in the examples, and you can put an example in the profiles folder. But it's always good to have this separate, because typically you will want the resources that are authored by different people, or potentially by different people, to be authored differently. So you might have a terminology group, and you can say, hey guys, you worry about the vocabulary changes. I worry about the extensions because I'm next to the physicians, and the technical guy is going to work with the profiles themselves. So this is the file structure that we have in our implementation guide, supports a bit of that distribution of work. The other type of content that implementation guide can have is shorthand resources. It's going on a dedicated folder. We will see all about this, but we can have examples, models, profiles, and terminology resources in different files, all under this special folder. We'll see how that works. And we can have narrative pages, or we can have images. So if you want to show a nice diagram that you made from a PowerPoint presentation, or a picture of something, you can also put images. Keeping in mind that we are doing the implementation guide publication for publishing narrative text, so really web pages with static content, and resources that provide the technical input to the implementers. So those things require typically text, images, and resources defined in JSON, XML, Turtle, or shorthand. The implementation guide artifacts, what it produces is the web page URL. I'm sorry, I did not update this link here because I will share this in the chat. It produces a web-based publication. I'm going to put this on the chat now as an example, something that I built before. And that's what we are going to do today. So yesterday I just did one implementation guide, or 2 days ago I did an implementation guide. And this is what we are going to do today. So we are going to have one implementation guide about food allergies. We are going to do the profiling, the value sets, one extension, a logical model, and some text. You're just going to see how that whole thing fits together, and how easy it is to work on it. But just to see, if you have the link if you open the link that I sent, this is what we are going to produce. A simple implementation guide with 1 page for introduction, and with the artifacts that we'll produce, so a logical model, a profile, and the value set, and one example. That's it. And you'll see that it's very simple to get started on this tooling. So let's talk a bit about the tooling as well. The tooling that we use is, as we mentioned, everything that we use is open source tooling. And today we are going to use the implementation guide publisher. So the processes that we use, sorry, let me just go back one. Yeah, so we are going to use this one just for mentioning. The implementation guide publisher is an open source tool that works offline or online, and it builds an implementation guide. It does a lot of checks, check the input, check if everything is consistent, check if you make an example for something, and if that example is consistent with your definition, it checks every link that you add in there to see if it's broken or not. It creates all those pages. It's a tool that provides all those functionality that you've seen there, and it's one single tool, and it's not something that you have to worry about, just for you to know what's going on behind the scenes. The specification process that you could use is, well, this is normal V model or even agile ready model. You just get the requirements, which in our case are data definitions, the elements and terminology that we need to use. Create a boilerplate initial content, so create one empty implementation guide, and then from there do the iterative cycle, which is see our requirements and see if there is someone else doing those requirements, because we might want to reuse as much as possible, or we might want to join one existing working group of people that are doing what we need, so that we don't have to reinvent the wheel ourselves. And based on that, you implement your content by adopting things that others have done, or by doing your own things, profiles, extensions, etc. And if you do this by checking that you're reusing as much as possible, you do it. You build your implementation guide. I will explain next what is building the implementation guide, and then you repeat this process. So it's better to always iterate to see this is the current specification, is it satisfactory or not, etc. So with this specification, or for this specification process, the tools that we are going to use today, or the tools that you typically use, you can do these things by hand using any text editor, which is not really appealing because you'll have to edit a lot of text. You can use Forge. Forge is a free for non-commercial use tool. It's graphical. It's very nice to see how things are shaping up. Even before you see them published, you can see the structures being shaped, taking their shape of tree structures. So that's a product that you can use. And in this session today, we are going to use FHIR shorthand. FHIR shorthand is a FHIR method and related to an open source tool as well. It's a way to type little text, and with a little text, without messing with all the JSONs and XMLs, you can do some experimentation and some profiling on FHIR in a very, very easy way. That's for creating content. For publishing, you have two choices. You can put this on simplifier.net, which is a hosted system where you put your content and it shows that your content to others. So it's great for sharing content with others. Or the FHIR implementation guide publisher, which is what we are going to use today, which just does the steps that I mentioned before. For editing the text, you would need some proper editing. I mentioned Visual Studio or Visual VS Code, Notepad++, even Notepad, anything will work. And since, as you will see, we are going to work online and offline, this is it's very good to have version control support on this. So typically we use, the FHIR community tends to use GitHub, and that's why we recommend that you set up a GitHub account. So these are the tools that you need to have the implementation guide, and we have just a quick overview just to wrap up this part before we go to questions and answers. What we are doing. So we are doing, and we are going to do today, we create the source content. So we create some configuration. In our case, we don't have to do configuration because that's already done for us, just because of we want to make it quick today. And we add text. Text can be markdown files, XHTML, plain2ML files for diagrams. There's a lot of things that we can add as text, and computable content. So the JSONs, the XMLs, and the fish. We call it the fish files, the FHIR shorthand files. So FSH is short for FHIR shorthand. And since it reads fish, you can imagine the amount of puns, and you will see the amount of puns that are made around the word fish and the concept of fish. So using these tools, or using the tools that we have, you will provide source content, and then you have two ways of working. So one is the offline or local build that we mentioned in our mails, and basically what you do is you take the FHIR implementation guide, publisher, and dependencies. So Jekyll and Sushi, the ones that we recommended. The implementation guide publisher takes one template. Today we are going to use this template, the OpenHIE template, because that's what we are using, and that will produce a static website on your computer. That's what you'll get. So if you have all the tools installed, you don't need to go online, except for one small detail, but you can build your own implementation guide on your computer. Or, and that's what we are going to do today, or I'm going to do today. I'm going to do both, but you can take that source content and put it in a repository, in an online repository. And if the online repository on GitHub is correctly configured, you can let that automatically create or run your publication and produce your static website and publish it on some place. So what we are going to do today is that we are going to create some content. I'm going to build it locally. For those of you who want to do it, you're free to do it if you have the tool set up. But also, most importantly, I'm going to show that if you use the tools that we provided or any related tools, you can do this. You can let the online tools take care of the build and dependencies, etc. You don't have to worry with that, and you have a working specification. And before we move to questions, this is the last slide now. The important thing about having publishable specifications is that when we go through those iterations, when we say, I made my profile, okay, then I can make my example. Here's the example. It's very important to share with others and to keep track of progress, because we want to iterate as quickly as possible. We want to validate with our stakeholders. We want to ask them questions. Is this enough? Do you need another example? Do you have any challenges on this? We need to show them something better than a big Word document with 200 pages. The implementation guide is really excellent for that. And there are several ways to do that. So once you publish once you create the content, you can publish it, and publish it means building and hosting it somewhere. Today we can, we are going to use the GitHub hosting, and if you have a GitHub hosting on github.com/or user and repo is the repository name, then you can set up the HL7 continuous integration builder to publish it on build.fhi.org/ig/the URL corresponding to your organization and to your repository. But the online template that we will give you today, it provides an internal automated workflow which automatically publishes it on this URL. You'll see the example now, but this means that you don't, if you use an example, or if you use a template like we are going to use just now after the questions and answers, then you will not need to worry too much about building this. If you're serious about implementation guides, if you have to make a few implementation guides, you should have your local build working. But if you just want to show something to someone, or if you just want to make a small change to someone that forgot to add one value in a value set or whatever, you don't need to go through the whole thing. You just go to GitHub, you change it on GitHub, you commit, and then a few minutes later you see the result already published. And this is the powerful thing. Once you see immediately the results of your changes, you can work much more quickly and much more collaboratively. So this is the introduction. I hope I was not too fast. That was not too much, but I look forward to questions now.
We've got a few in the Google Docs. I'll just go ahead and read them out to you.
Thank you.
The first one says, can Fish or Sushi retrieve code systems and value sets from other terminology servers? For example, if we wanted to bind a resource to a value set hosted in FHIR, such as gender value sets, but not the base FHIR website, is that currently possible?
I don't think so, because I think Sushi just looks at the specification of the value set, not the hosting of this. I haven't tried it, to be honest, but I don't expect it to be possible. But in any case, if you have this value set, I just opened it. If you have this value set on a happy server, the value set there, I'm just going to bring it up. It should have a URL. And if it has a URL, then you might be able to track the author of this. So you might want, in this case, you might want to talk to Graham to see if it's defined in an implementation guide, and that you can do. So if someone says, this is on the server, but the definition is in this implementation guide, you can actually tell your implementation guide to say, hey, I will use external content here, and you can find external content in that implementation guide. So that you can do. So I don't think Sushi can use definitions straight off a FHIR server, but I know that Sushi can take those specifications straight off the specification where this is hosted. I hope that answers the question.
It looks like the person is taking notes. Okay. Next question. What might be your advice to countries? Start with US core or international patient summary?
I don't know if I mentioned this in one of the previous calls, but so I like the I cannot have a preference there for one simple reason. The US core is supposed to have core elements for the basic functionality. And it's US specific, and it was very early made. So there was some assumptions made in the US core. I don't want to be picky, but there was one that was rather discussed, and the US core was already published at the time. So that was one thing that we could not go back with the specification. There are downsides to using something that was made for a specific purpose like the US. The international patient summary has the good thing that it's international, but has a downside, slight downside, or maybe big downside, depending on what you want. I will get into that detail, that it is a summary. So the international patient summary is not supposed to, for example, to support that you, let's make a specification about prescribing medication. You cannot do this out of the IPS. You can take something out of the IPS. So there's lots of considerations, good considerations that are in the IPS, as long as you keep in mind that IPS is summary. So it will have some things that are interesting for showing a summary, and a summary is really a static document that represents a snapshot of a given status of health data. So if in your country, if you want to go, if you want to implement that you can use the international patient summary. To be honest, I would look at both. This is just my my adventurous feeling, but that's also what I did before. I would look at them all as much as possible, and I would just make my own choices and use part of the US core and part of the summary. But if I have to give some more clear guidance, if you want to start, see where you are, on which side you are. If you are in the side of, I want this to be exchanging of documents, between discharge summaries or things that are related to continuity of care, you might get more good ideas from IPS, and you might, of course, then you might build your layer upon the IPS. If you want things that are more workflow related or more dynamic exchange of data, let's say if you want to do lab results, etc., or sorry, lab ordering and results, you might look at other specifications, for example, the US core. There is no universal answer to that question. I'm sorry. I think there's no answer. Maybe someone has a different idea, but in my view, you have to weigh the ups and downs of each.
And our last question for this question and answered. Can you explain how the directory of published versions is generated and how it links to different versions of the specification?
Oh, that's a good one. I was not prepared for that, but I can show you one example of that. Yes, I will. So the directory of published versions is something that you can do, so that we do in the FHIR specification, and we can also do when publishing an implementation guide. I will give you one example. I will search for it meanwhile, but I will give one example of that. But basically, once you publish, actually, let me see if I can bring that example now very quickly. The one that I'm thinking of is what? Okay, let me just show you the FHIR one. So what? Yeah, this is specification. Let me just show you the I think it's the MHD. Let me see what we have here. Yeah, so I presume this is what you mean. So when we publish a specification, we know that this is going to change. We have review cycles, we have publishing cycles. When you look at a specification, you have a version, of course. So my specification has this version, your specification will have that version. And it's always good to, and you can expect that you need to support your implementers to be in the previous version or in the current version. You don't, if you have a roadmap for implementation, it's very unlikely that you have everyone always on the same version of whatever you did, because if you do a change now, it will take some months for them to onboard those changes. And for that reason, you might keep the publication of both specifications in parallel, so that you can always point at the latest version. For example, this is the current version, but if you go to that link there, you see the directory of published versions, and you can say this is what it was before and was the version before, etc. So this shows a bit the history of changes, which is very important if you have to support different versions, which normally you would have to support, because I think there's no expectation that everyone will always be on the latest thing that you published. Joel, I hope that answers your question.
Yes. Just a quick follow-up. Do you have to have a new Git branch for each of these, or is it just working off the one branch?
No. Okay. The way that it works, I'm going to summarize it. The way that it works is the following. When you have a version that you say, okay, this is it, we are going to publish, you run a special process, you run the process for publication, and that freezes what you have and says, okay, this is going to now be frozen forever under this this tag here. And then you can do this on the master branch. Normally I do this on a candidate release branch. So I make a release candidate branch. I make that release candidate branch. I clean everything that I have there. I clean the content that I don't want to be included. I clean the issues, and I use that for input from the field, etc. I use that so that I don't contaminate the continuous build. But from that branch, from the moment that you have that branch, you say, I want to publish this as one version. Then you run that process, and that process freezes that specification. And the next time you run the release process, the first one was already frozen. So whatever you do after you freeze it, so basically you freeze the HTML output. So you produce the HTML output and you say, this is it. No one is going to republish this anymore, because it gets copied into a specific folder, so it's not going to be built anymore. You can still build your main branch again, but you don't have to do anything like tags and releases and branches. You don't have to. We might experiment a bit with that to see if that would get any easier, but you don't have to. Basically, what it does is freeze the whole thing and just publishes the pages. So if you add a new version here, the old ones will not be touched at all. They will just exist there. The list is going to be appended by one element, by the new one, but you don't have to do anything about them anymore. You cannot change them anymore.
Thanks, Joseph.
Okay. Any other questions? I see a few.
No, time to move on.
No? Okay. So if I can catch some breath, I would like to just go to the next part and just do it. Where is my? So for today, we are going to use the following tools. GitHub, and we are going to use the online build process. For Git client, I'm going to use a GitHub desktop because that's what I have installed on my machine. You can use any other things. I was just ignorant about how to do that in my Visual Studio or VS Code that I have on my machine. So otherwise, I could even save one tool, but it's not. I hope it's not bad to show you those two tools. For profiling, I'm going to use Sushi. The template that we are going to use, it comes out of the box with what we are going to provide as a boilerplate, and the publishing is going to be with Implementation Guide Publisher. So if you look at the options that we have in terms of tooling, in this session we are going to use these tools because they are more comfortable for me to work with. They are all open source, so you can start with them now, and the learning curve hopefully is not very steep for you to get on with the basics. So let's just do it. What we are going to do is First thing, we are going to create an implementation guide and set up the implementation guide repository locally and online. So if you remember the previous diagram that we have the build process where we can do things online and offline. This means that we have to have online files and online repository, online files, and offline content as well. So basically the choice is, where do we start? Do we start with something local and then we upload, or do we want something online and then we download? Today I'm going to use the online tab, online first and then download, which means I need to configure it. So I'm going to start with a boilerplate that has a dummy name. So I'm going to make my own implementation guide, and then from that I'm going to get all the content. I will add some narrative text, a logical model, profiles, value set, an example, and I will check the output quality to see if everything is fine. I'm going to start online with GitHub because it will be easier and quicker. There is another way, which is if you have sushi, you type sushi in your computer, and it creates locally these files, which then you would still have to upload. And as I said, for me, it's easier now to start online, because there's a couple of things that quite some steps that we can save by looking at this. So the steps to create IGDA. So the sushi init command creates something. It just answers the questions like, what's the name, what's the idea of your implementation guide. I'm not going to go through this. All the documentation is available in the links that we will provide, and actually that we provided already. But if you want to start remotely, as I will now, you can go to a template repository, which is the one that I'm going to open now. And actually, that's what I'm going to do. So you just go to this GitHub repository, which we configured as a template. Let me just show it to you. So this is the URL there, and this is configured as a template. So you don't have to worry about what's behind it, but you can just use this template, which is what I'm going to do now. And I'm going to create an implementation guide. So this is what we have to do. I'm going to create it just for having it up. This is okay, because if I do it in my own account, it will conflict with what I have. But let's call it food allergy. So I'm just giving it a name. You can give it a description. I'm making it public because I want to publish those pages, and it's very important to click that flag, that checkbox here, because if it's active, then your publication will be automatic. So if you do these steps and you create your repository, I have just clicked a couple of buttons, and with this, I have already created a working implementation guide. And it should now be building. Let me see if I refresh my screen. Yep, there is now a yellow dot here that says this is building now. So remember the tooling that I mentioned to you, the tooling that runs online. This is it. You don't have to worry about it. It runs everything runs in the background. Whenever you do a commit to this repository, so when you change the content of this repository, it starts building, and you don't have to worry about this. It will take 3 minutes, so I'll move on to the rest of the preparation, and then we'll come back to see how it looks like. But this is all you have to do. So if you follow these 2 steps, you just have your implementation guide. That's it. You can do it on Sushi and then upload, but that's why we chose this approach. Now that I have it there, the next thing I have to do is to synchronize it, so to bring it on my computer. So I want to add content there. The easiest way to do this is not to do it online, but to do it on my computer. So I'll just go and copy that content into my computer. Let me just get the content, and to do that, GitHub, what you do is, if you have GitHub desktop installed, you just do this, and it opens something. It asks you, where do you want to clone this? Okay, I'm just going to create it on my own folder. I'm creating a folder called Implementation Guide / Food Allergy Webinar. I just have to say where it is, and when it's done, it's done. So I have all the files here. Let me just open this on my computer, and you see this is these are the files that I have online. So this is now synchronized. If I change one of these files, I can now upload them. So that's exactly what we are going to do now. I'm just going to open this file on on my editor. So this folder on my editor. It's just a shortcut, but you see now the folder structure. I have input files and I have local template just because I had I have this prepared if you want to change the colors of the template, etc. That's what it's for. But today we're not going to do that. We're just going to use the input folder. So the way that we do this is always the same. If we have this is about my implementation guide. I'm just going to show you the implementation. This is the implementation guide file. So the main content of this, it's an implementation guide resource, and it has a URL which is dummy, and it has a contact point which is also dummy, and all those dummy variables, those dummy parameters, we have this as XX. I mark this as XX. So if I go here and search for XX, I have all the things that are dummy content. So if I want to make this as my food allergy implementation guide, I just go here and change this, the axis for what I need to change. Before I do that, I'm just going to show how the online build is working. Let me just refresh, and this flag should be green now. It is green, and because it's green, it now has, I have an environment here. I'm just going to click the links just to make it easier for you to see, and then I can view deployment, and this is it. So this is the implementation guide I just created 3 or 4 minutes ago. This is it. It has no content. It has a very simple table of contents with just the default content. It has the header and footer. The tooling does all of that. We don't have to worry. We just have to worry with stuff it with content. That's what we have to do. So this you see the URL is, as I mentioned before, is the organization.github.io/repository name. It's always the same thing. So you will have a different URL, of course, for your implementation guides, but this is what you have. So when you create an implementation guide, this is what you have to do. And now we are in a position that we can change the content and add content. So the next step that I have in my agenda is that, or in my changes to do after I synchronize, is to give it a proper name. So I'm just going to give it a proper name now. I'm just going to give a so for example, openhi.fire. Something like this. Let me just take this out. There are some rules for consistency here. These two should be consistent, and hopefully, actually no, it's even simpler to do it like this. So let me just to make it simple. This should be there, and this should be also consistent with that one. It's not mandatory, but it will help in that publication step that I was just showing before with the IHE stuff. We don't need to care too much about that. We just need to care that the name is not this. So the name is, it has to be a FHIR name. So no spaces here, has to stop with an uppercase letter. And this is the, sorry, let me just zoom in a bit. This is, let's call it food allergy, for example. I could call it my food allergy IG, and then we give it a title. So food allergy guide, and then we have the publisher is FHIR, for example, and then I have whatever it is that you want to put. This is your configuration, so you do it what you want. You can put a short description of this. It's allergies. So you can do that. So you just add this kind of content. Let me see if, yeah, there is still another package ID there. There's still a couple of X's. Let me just call it I did not forget the syntax, and I'll have to open it on the side just to remind myself. So I've just changed this file. Oh wait, this is sorry for using just the short names for this, but yeah, I just changed one file, and the other thing that I'm going to do is now to rename this. It was called myIG, just to make it easier on myself. I'm just going to rename it and call it food allergy. When I do this, and this is a very important step, I will show you a place where you can see all these instructions being, or these steps being played. If you have the food allergy, when you start the build, when you start building, the tooling is going to see which XML file do I start with. So we have to give it some indication of which XML file to start. It was configured to use the file myig.xml, but now I changed that file, so I have to go to this special file here, ig.ini, and change it to food allergy. This is the most complicated part of what we are going to do today, I think. Just keep this in mind. You have to change, if you change the name of this file, you have to change it in the implementation guide.ini. That's it. If we have this, we have now just slightly configured implementation guide. Just because I can do this quickly, I'm just going to run the local publishing. For those of you who want to see how it works, I just opened a command line on that folder, so that's what I did, and I'm just going to do the thing that I have to do always is to run this script. gen1.bat if I'm on Windows, gen1.sh if I'm running on Linux or Mac machines. I'm going to do this now, and it's not going to work because it doesn't know where the implementation guide is working. Don't worry about that. Just keep in mind that if the first time you run it, you have to do the update. You have to run the script update publisher.bat, and then you press yes. It will download it. By the way, I'll just forward in the slides because this is exactly what we are doing. So I just changed those things over there, and as it's explained here, you run the gen1.bat. If you need to, you run the update publisher. If you do it online, you don't have to do anything. Those are the URLs that you saw, as you saw. So if I go back to my build, I don't want to update the scripts, and then I can do run gen1. Depending on your machines, just for you to know, when you're building it, it can take, in this one, it will take 30 seconds or so, 40 seconds. In a older machine or with less memory and slower CPU, it will take 2-3 minutes, depends on your hardware. But it takes a couple of minutes to do this. So there's a fish pun, and we have, so Sushi is building. I will share in a second what Sushi is doing, and then the implementation guide is doing all those things that we have mentioned. We will see those in practice, but this is what's going on behind the scenes. It's checking versions of everything that's working on. It's getting the base content that it needs. It's creating the pages. It's publishing all everything. And I'm going to show it now. Should be a few seconds. It's going to, yeah, and it's creating some content. So if I go to my file structure here, you see that I already have now more content. I now have an output folder. If I go to my output folder, I can do it like this. Output folder /index.html. I have this thing, and this is local. So the same thing that we had before, we have now locally. Of course, this now says food allergies implementation guide. This one still says your username because online I did not change it yet. So what I'm going to do now is exactly to go back, and since it works okay now, I had no errors. I can go here and say, okay, I changed this file, I added this file, and I removed this file. Sounds right. So I'm just going to change information. Just going to commit, and that's pretty much what we're going to do for the next half hour or so. I just created my first changes to the boilerplate implementation guide. So in a few minutes, this is going to be changed, and I can see that because if I go here and refresh it, it's already building again. So it already took my changes. So 16 seconds ago, it took that, and it's now building. So when it finishes building, if there is no errors, then it will show this page up to date. So on with the fun stuff, things that we really want to do now that we know how to create an implementation guide. Narrative pages. So one of the things that we do in an implementation guide is to add text, as I mentioned. Let me just bring this window to the side because I want to copy the text so that I don't want to type it all by hand. We'll start by adding some narrative, and that narrative we are going to start with a page, and that page is going to be an introduction page to allergies. So what I have to do here is to go in my implementation guide, and if you remember in the one of the previous slides that I had one place for the page content or where the narrative is going is this one. So I'm just going to create here a new file, call it intro.md, and I'm going to create some content there. So I'm saying MD, so this is markdown content. So I'm just going to copy and paste from my other screen into this one. It's just a bit of text. So you can make up your own text. I cannot stop for typing all these things, but just as you understand, for sake of keeping the pace. But you can put any blah blah text over there. It's going to be the same result. When you do that, and if you remember from yet another slide, the implementation guide knows which pages it is processing. So now what I have to do is to go to the implementation guide resource and add the page and tell it, hey, you have a new page that you need to document, or you need to produce. So I'm just going here, and this XML file, it could be a JSON, but this XML file reflects exactly what the structure that we had in the UML diagram before. So I'm just going to go here, and after the index, I'm going to add this content. So this is just FHIR language. So if you have the oops, let me just copy it before I paste it. As you go and edit the file, or if you become more familiar with changing the FHIR content, this is not, there's no secret behind this. It's just the normal structure. So there's a parameter which has the name URL. There's a title and a generation. So you have to put the right content here. For us, this is markdown text because I created a markdown file. The page title is going to be this. So that's the section name, let's say. And it's going to be shown as intro.html in the publication. So that's what we need to do. Once I do this, I just created my page. So I can actually commit this one now. So I just go here and back to my GitHub, and there are the changes. So I could say now, create narrative. I'm just going to leave it here. I'm not going to push because the other one is still building, or maybe it's still building, and I don't want to do a build for every step because you see already how it works. So there's no point in stopping a few minutes to build in every step. The more interesting part now is the profile. So what we did is what's described on the slide. So we add a page to describe food allergy reporting and sharing, or in this case, food allergy intro. And don't forget to add it to the implementation guide XML. That's what we just did. And now we are going to add the logical model. So logical models, as I said, is a structure definition that represents an abstract data object or a data structure. It's based on a special resource base. We don't have to worry about that. So what we are going to do is to add the logical model, in this case for food allergies. So suppose that we want to have, so the steps is going to, we are going to add a fish file to our repository, and then we can see more about sushi in this link. I'm going to show you the example right away. Let's say that our stakeholders, they said, we need an implementation guide that supports food allergies. We need to put something in the market for food allergies. Then our question would be, sure, what data do you want to exchange? And they will say, I need patient. And we say it's mandatory or optional. Yeah, of course it's mandatory. Okay, then we have this kind of discussions. And if you have this data, this definition, so patient, clinical status, verification status, the allergen, and in the allergen, you would say, please give me the list of codes because we are not going to browse through all the snowbed and log to see which codes we should use because they want it coded. So we have to ask for a list of codes. They also said we want to capture the data recorded and the recorder and who is the asserter. If the asserter is known, like if it's the patient that says to the doctor, then the doctor is a recorder and the patient is the asserter. And if there is any known history of reactions to that substance that the person is allergic to. So suppose that you have that as requirements. What you have to do now is to create the structure definition for that logical model. The way to do that, and I can put this link on the chat. I just prepared that for you. So this is how it looks like in shorthand language. I'm just going to put it on the chat. So just if you want to see it, because this is for me to introduce this tool. So the Fish School here. This is the site where we have lots of information about how to use sushi. The syntax of sushi is described elsewhere, but there is always links. So this is a perfect starting place for you to use sushi for your implementation guides. And there is a small one part of that website which is play with sushi online or try sushi online, which is what I just did. We would just add content, and if I want to put my content without going through those 3 or 4 minutes of building and see if it works okay, I can just go here and define my content in the sushi language format, and I can click this button and say convert to JSON. Oh, okay, it works. You see here there's a success flag, so no errors. I see it working. Good. Then this means that I can include this content in my implementation guide, and that's pretty much all that we have to do. I'm just going to do here one typo that I just noticed. That's it. But that should not change. And I'm not going into the details of the sushi or the shorthand syntax, but the syntax to do a logical model is this one. You have the keyword logical, and you define the name, the title, description, and then you put the data elements one by one, and then you put the name of the data element, the cardinality. So this means it's mandatory and maximum 1, and what type of data it is. So in this case, it's a reference, and the person that has, and then we have a description of the data element. Actually, 2 descriptions of the data element is required. One is a short description, the other one is a long description. And that's what you do for every line. And remember that we spoke about terminologies today and in last month. So this is one example. We have, if we want to say, this is the allergen, so the substance that is suspected of causing the allergy, then this is a coded thing. And as we've seen before, we don't want to have it as a code. We don't want to have it as a coding because it's not very common. We want to have it as a codable concept. So that's our default choice. We choose it as a codable concept. And then we do this forever. And the indentation here that you see is that the manifestation is a property of reactions and certitude as well, and exposure as well. So these are the data requirements that they wanted to see. So that's what we are going to give to them. And the way to do this is very simple. I just go to my implementation guide, and there is this reserved folder that I mentioned here, which is FSH. I have already here a thing called models, which is empty. I'm just going to paste it there. I could add it to another file. We can create as many files in this folder as necessary. This is just one boilerplate content, so you don't have to stick to this. I can name these files whatever I want, and I can put many things in the same file, or one sushi element or one sushi object per file. So I can have, if I have 5 profiles, I can put them all into one file, or I can have one file per profiles. It doesn't really matter. What you have to make sure is that it's under the FSH folder. Once you do that, then your logical model is there. So while I advance with the profiles, let me just do just that. I should validate this locally, but it'll take me 30 seconds, and I'm pretty sure because I tried this, so I know that it works. So I'm just going to do this and commit this to the online repository, and in a few minutes when we look at it, it will be there. The logical model will be there, and we will see how the logical model looks like. So while that is cooking, let's see what else do we need to do. So we added that content. So we want to add a profile. Sorry. When we make a profile, what we are doing is to define a structure definition, which is a set of data elements and their characteristics. And data elements, they can have lots of variations, so we can change the cardinalities, the binding, as you've seen, the short description of the element, even definition, the long definition of the element. We can select those. So what we are doing here is to create a profile. So as we've seen in the first part, we choose our base profile. So if we would start with US core, maybe US core has a US allergy intolerance. And if we want to do that, then we start with US core allergy intolerance. In this case, I'm going to start with the FHIR base allergy intolerance in release 4. So I'm going to start with this resource here. And what I'm going to do is to create a structure definition that changes some of those elements, the cardinalities, the short descriptions, the definitions. And if you want to see how the whole thing on sushi is defined, so shorthand is defined in this URL. This is the language reference. It's very comprehensive and very detailed, so you can go there for learning how the syntax works. I do this every day because I many times forget some details. And so how do you make a profile? So that's a bit more practical aspects. How do you make a profile? One approach, and this is the one that I prefer to follow, is if we have a logical model, start with that and map the logical model to the resource. So if you have something mentioned in your logical model, make sure that it's marked as must support in your profile. I will explain in a second what that means. If the element is not there, so if you have something in the logical model that is not in your profile, this means that, so it's not in your resource, sorry, that this means that you need to extend the resource. So if our logical model had a thing called certitude, I think, yeah, and this is not existing in the FHIR resource, so we have to go to the to add extensions, and if there are changes, then we add constraints. Pretty much this. So we look at the base resource, and we have our logical model on the other hand. Then we say, okay, my logical model mentioned a patient, and it's mandatory. Okay, let's see. Patient is not a patient here, but there's a thing called, I think there's a patient even. I thought it was called subject, but it's patient, and it's 1-to-1. So we don't have to do anything except mark it as must support. That's what we want to do. We already have a clinical status as well, and it's mandatory. So let's see, clinical status. It's 0-to-1, so we have to make it mandatory. The same thing with verification status is we have to make it mandatory. Also the code here, we have to make it mandatory. So it's 0-to-1, we have to make it 1-to-1. And you see, this is just going through the logical model of our data and going through through each element and saying, what do I need to change in the core element so that it becomes compatible with what my requirements are. And you do the same thing. So record date, it's optional. So we just need to put it as a must support. So we just need to flag it. Recorder must support, asserter must support, reaction must support. Everything is the same except for certitude, which does not exist here. So we need to add an extension. That is, let's say, the most complex thing that we are going to do today, and you'll see it's not really complex at all. And if you just look at this, this short list here, which is what you need to change, you'll see how remarkably similar it is in Sushi. I just click the link, and I'm going to put the link on the chat as well for those of you who are building this. And oh, sorry, I forgot to mention it, but when you do this in Sushi, if you are playing with this, and if you want to share it with a colleague, or if you want to get feedback on this, there's a nice little button here which is share this, and this will create that link, which is exactly the link that I shared with you. So if you share this link, they will open this page already with this content. If I just open this thing without that, then it's just going to be an empty page there, of course. So, and if you see, this is exactly what we had. So the patient is must support. That's what we had in our thing here. The clinical status, we make it mandatory, and why not must support. So you see, 1-to-1 must support. Verification status, 1-to-1 must support. The code is mandatory, must support. Everything else was must support, except for the certitude, which is, and then what we do here is always the same. We see where do we, so how do we define the certitude? We have two choices. Either we have lots of discussions around this, or hopefully, if we are lucky, we go into this special page that I don't think we have the link for this, but I'll send the link anyway. We go to the FHIR extensibility registry. Actually, it should be FHIR. So we go to this to this page here. This is the list of standard extensions in FHIR. That's what I mentioned before. If we have a broad community of people saying, yeah, this is not really core specification, but if you do it, you might as well do it in a standard format. This is where those extensions live. And for our purposes, you see one here called allergy intolerance certainty. That's really nice. Let's see what it is. Statement about the degree of clinical certainty that the specific substance was the cause of the manifestation in this reaction event. Sorry for talking too fast. This is exactly what we want. So this is what we want. This means that we can use it. And you can see in the shorthand syntax how to use the extensions and how to use already defined extensions. But this is also this is logical model. This is exactly how to do it. You have the profile. So you have the profile, have all these things there, and you say under reaction. Remember that I said that everything can be extended in FHIR. This is the case. In this case, I'm putting the extension here, not in there. So I say extension contains that extension. So I'm just pointing to the URL of that extension here. So what I did is go here, not this URL, but this URL, and this is very important. This is defining URL for that extension. That's why for Alvin, when you asked about the value set, I did not go to the URL of the server, but I wanted to go to the URL of the value set, because that's what matters. This is general information that might be saving you a few clicks and a few typing sessions. So we take this URL and we put it here. So we say in the extensions of the reaction, which we can have several, I want to make sure that we have that extension. So the extension defined by that URL, and we call it certainty, typo, and we make it optional because it was optional, and we make it must support because everything that we have in our logical model, for us to keep track, is must support. We try this here just to make sure that we take 1 second to validate it. Okay, it seems to work. So I could copy this into the implementation guide, but the easiest way is just to do it in Sushi. So I'm just going to do just that. Select, copy, copy. And I'm going to go here. Oh, not here, sorry. And do my thing here and create a profile here. Now, unlike the pages, when we create profiles, the publisher takes care of taking that. So we remember that for adding the intro page, we had to go to the food allergy and say, implementation guide, you now have another page to render. We do that for pages, but not for the profiles, for the technical artifacts. Those are picked up automatically by the publisher. So you don't have to do anything else. They will show up automatically on the implementation guide publication. And that's exactly what we need to do. So I will just create that commit. So I'll just add profile, and then I'll just commit. And I will not push yet to the online. I'll just quickly check how the online build is. It should now have a logical model. Let's see. Yep, it built okay. It has a food allergy logical model. I can see it from the table of contents, or I can go to the artifact index and see that there's now a logical model. In the logical model sections have a logical model. And this is how the logical model that we made looks like. So there's lots of data here. And in terms of navigation, you have to get used to it, or maybe we change it. There's a text summary, which doesn't say much. The good thing is in the differential table and the snapshot table. So which in this case is the same because it's a logical model. So if you have this, we say this is what we mentioned as the input requirements: the patient, the allergen, the clinical status, mandatory, verification status, etc. All of these with the right data types. And as I mentioned before, this is exactly what we bring to our stakeholders. We say, hey, Dr. X, do you agree that this is the information that we need to capture about allergy reporting, food allergy reporting, yes or no? This is the level. So it's not yet a FHIR implementation, it's more abstract level. This is what we bring to them. So from now on, we can validate this with them. But the other thing that we wanted to do on the implementation guide is to also play a bit with the terminologies. I guess, let me see if that's in the right sequence. So we were profiling, yeah, we had a value set. So value sets are for coded elements. Remember to choose your strength. If you want to do food allergies, you might have someone that is allergic to lemon, for example. And if they are allergic to lemon, if you make the binding required, then you are basically saying that we will never capture allergies to lemon because that code does not exist in our value set, which would be an issue, I think. I mean, I'm taking some decisions as we would need to validate them with the stakeholders. But if the stakeholders say, no, we don't want anyone to report any lemon allergy, we just want those 12 allergens, that's fine. But in this case, I chose to have a extensible or preferred binding because we don't want to be too strict on that. And the let's say we use these 12 allergens: peanuts, tree nuts, milk, eggs, fish. So these ones that are here. I took this from I think it was from Wikipedia or from some other website. There was also the allergy to gluten, but gluten is not an allergy, so we don't have. I excluded that. And as you can guess, creating a value set is also a technical thing, so it most likely can be done in sushi, and here it is. So this is syntax information, but to declare a value set, you do this: value set and title description, and then you add the codes. And how do you add the codes in a value set? You put the URL and the code, so URL and then hash and or the pound sign and then the code. But if this URL gets long, you might as well make an alias for this and say, I want to represent this URL by this, and then so this is the same thing as having the URL here. Yeah, and if we go through SNOMED, for example, we have allergy to peanut, allergy to tree nut, etc. And then just a finding that we had I have not discussed it with anyone, so I'm just sharing with you. I noticed that there is no allergy to sesame seeds in the edition of SNOMED that I was checking. So I don't think this is the correct code. So I can add comments in sushi and say this is not the correct code. One could not be found because the other one are allergy to peanut. So there is a SNOMED code for allergy to peanut, and there is another code for peanut. And between those two, I chose allergy to peanut because this is the code for the allergy, not the code for the substance. If locally, if you decide otherwise, you can. You're not really following the orthodox guidance, but you can. And in that case, we would use substances for all of those. But this is a problem that you, as an implementation guide creator, your job is to raise the flag and say, hey guys, I have a problem here. I don't think these codes are correct. But that's mostly for the terminology people to solve. You know what I'm going to do now, which is going here, looking at my terminology, pasting those things, and that's it. I just created a value set. Now the problem is that I did not yet bind my codes with a value set. So I have to go to my profile again and say that the code here should be bound by my value set. The way that we do this in FHIR, again, I don't want to do the to go through the sushi the whole syntax. The way that you do this is do this code from, and then you put the name here. So food allergy VS. If that's the value of the name of your value set, then you do here from. Yes, this creates the binding. If I don't do anything else now, it creates a required binding, which is not what I want. So again, using the syntax here, I'm just doing this food allergy VS extensible. This is it. Looking at the time, I now can afford to do this generation again locally. And while it's doing locally, I'm going to check checking those changes to the online build because I'm pretty confident that they should work. Add set and binding. Good. And let's see it. So the last two commits that I did was the profile, the value set and binding. Okay. And now that we have this, the only thing that we could add on top of this to validate. So of course we can add more pages, diagrams, we can add lots of things. So, but just to wrap up now, I'm going to add one more thing, which is the example. I'm not going to, oh, I had an issue here. Oh, I had an issue in sushi. Okay, well, this will happen to you as well many times if you do it. So I have an profiles.fsh line 9. Oh, sorry, I should not use this. I have to repeat the line code, which means that I have to, I was too confident before. It's good that you've seen the issue. And now I have to go here and say, oops, and then commit that change. Good. The only thing that we need to add, or that we can add on top of this, is really just an example. So as for the other ones, I have the example there prepared. So you just have the content which you would create. So the example, you just create an instance of a resource, and this resource is food allergy, not allergy intolerance, but this is food allergy, because food allergy is now our profile. And we just put a few things. We put the patient identifier, and we put the patient name, and we put the oh, that should not be patient. Yeah, patient display. Yeah, because it's a reference. We have the clinical status, the verification status. Those are the codes of HR7. The code is allergy to peanut as we define it, the recovery date, etc. So we just make this simple example. We validate if it works. It does. Oh, it does not work. Why doesn't? Ah, because it doesn't know the food allergy. I have it in a separate thing. So if you excuse me, I will not even try to validate that because I did that before. I will just put it here, and it's really the same way of working as before. We just go here, go to the examples folder you created here, and when Sushi runs this, they will have Sushi will know where to find the food allergy profile, so it will be able to build the whole thing. And with this, we have basically covered the whole process. Yeah, so everything is working fine. So actually can go there and commit, because I wanted to show you, but I'll show you locally because the build takes just a few more minutes. The online build takes a few more minutes. Add example, commit. So this one should be almost ready. The final thing that you can do when you're doing the final thing that I wanted to share with you before some additional notes is the after you build, there is one very important page. So I'm just going to show you when it's done. Yep, this is it. Let me just go to the index page on my local machine. The online will be exactly the same. And you have at the bottom here, you have a thing called QA report. This is very important. It shows whether there are errors. Yeah, this error it's implicit with the tool, so I could not fix it before, and I don't even know how to fix it. We have to ask for some changes to the Sushi tool or to the publisher, because this was just found recently. But besides this, which is an error, if you make some issues or some assumptions, or if you put the wrong codes here, or if the links are broken, you will see all of that here. So this QA page is very important, so that because the whole validation, the implementation guide, it validates the whole thing, and the result of that is here. So you should always come to your QA folder and see that you don't have issues. Issues will be like the URL is not right, or the URL for my peanut allergy does not point to the right place in the implementation guide. So or you put a code without the display, you put a code without the system, which makes it impossible to know what does that code mean. This is very important feedback that you'll have there. And let me see how the build is working. There's still 1 minute to go or so. So this is it. And from that moment on, what you can do, and I'm not going to be able to show it today, but we can do it is you can use it in a validator, or you can deploy servers. From the moment that you have an implementation guide, you can run a command line. Ask us on chat.fhir.org how that works, but you can run a command line to deploy your own happy server already with this content inside of it. So that makes the whole ecosystem is becoming more and more user-friendly or DevOps friendly. You can use it in a validator. So you can now say, if I make my examples, can I validate them against my food allergy profiles? Yes, you just download the tool. There's much more to know behind this, but you can use this implementation guide to validate examples made by others. So if someone creates an example, you can use your implementation guide to validate this. Some additional notes. I know that we're short on time. The things that we've seen is really the most basic, or the most essential fundamental content of the implementation guides. We documented data structures and terminology bindings. We can define more things. We can define how to aggregate data within a bundle, how to do compositions, message headers, etc. Because those will be how you exchange data in a document format or in a message header format or in a messaging format, sorry. You can define operations and search parameters. So those are also FHIR artifacts that you define. You can define other requirements in a narrative format. For example, if there's a requirement like no patient can have the same allergy twice in the server, if you would have that, that's very hard, to my knowledge, to define in a FHIR implementation guide, although it would be nice. But that's very easy to write some text and say, whoever implements this, they shall make sure that no duplicate allergies exist. So kind of a wrap up here. Check out the implementation guide registry here, because there is already a lot of implementation guides that are out there that maybe do something that you can reuse, or they do exactly what you need to do. The sample IG contains some of these techniques, but to be honest, after this session today, you have your own sample IG, so you can use that one with the standard techniques, and you already have even the sushi stuff. The FHIR guidance IG is for more advanced stuff like changing colors of your implementation guide, adding the logos, adding some features. You can do that check that on that. I would love to say that this documentation is very abundant and complete. It's not. So if you want to volunteer to help build something as you find some new ideas, do it, and always check with us on chat.fhir.org. If you're stuck with anything, just make sure that you catch up with us on chat.fhir.org, and just, I think this should be built by now, just to show what we have. Yeah, there we have. This is our own implementation guide. I hope you also, if you tried it, I also hope that you got to this point where you have a logical model, the profiles, value sets, and the example. And just for the fun of it, while we open for questions, the example is shown. If you do this in sushi, or if you have, there's another way to do it. When you are looking at the profile food allergy, you can say, show me the examples of this, and it shows the example, and you link to that, and then you show the example, and the example you can show it as text or as JSON or as XML. So this is the way to navigate. I do not go too much into the navigation of an implementation guide, but that's it. You just look at the content, and then look at this in JSON or XML, whatever you prefer. You use it. You share this with others, and that's what you do. So I would open for some questions in the few minutes that we have left.
Yeah, so we have a few in the Google Doc. The first is the IG file expected to be XML, or can it be replaced with a JSON version of it?
JSON is also good.
All right. Question number 2, can you please confirm if you're doing a local build, simply download the starter IG guide template and run sushi after changes are made. If you need to publish the IG, upload it to GitHub. What is missing for me is how to do GitHub artifacts get processed thereafter. Is there a hook? Can you explain how this works?
There is 2 ways of doing it. I mentioned that there are 2 ways of doing this. There is the HL7 continuous integration hook, which I did not use here for sake of, I did not want to demonstrate, and because the other way to do this, there is a workflow here which comes out of the box. So when I click if you remember, when I click this button, use this template, it comes with a workflow. So it's an internal GitHub thing that takes that basically says whenever you push or you make a pull request, it does a couple of things, which is publishing the implementation guide on that page. That's it. So that's the magic that's behind the scenes. It comes out of the box. You can use this or the FHIR continuous integration build, which, if I'm not mistaken, there's also the link in the presentation. And yeah, those are 2 ways of doing this, of doing the publication online.
Perfect. Okay, for SNOMED, can we do post-coordinated expressions, i.e. multiple codes?
Can I plead incompetence here? I do not know what post-coordinated expressions are. So I think you can do there pretty much, so you can define your value set in any way that you can do this in FHIR. So the value set can be defined in many ways. I think so. Let me see, just from the top. Well, I mean, I don't know, but let me see if I have this information here. If I have an example of, no, I don't see it here. So I would not be able to answer this. The best place to have that answer, and that's what I would do, is chat.fhir.org and ask in the terminology stream. if that's possible. I'm confident it would be but maybe I'm mistaken about the whole thing because I do not know what post-coordinated thing is. So sorry for that.
I'm going to do a quick one and then come back to the one where there's been a little bit of chatter. So can you bind your profile to a logical model so that errors are thrown if something is missing?
No, you can do a mapping. You can make a mapping, which is something that we are hopefully working on with the FHIR community. We are going to work on some way to make that easier for you. It would be nice to say, well, you can actually make some links. So let me just show it very quickly. In the structure definition, a resource structure definition. In the structure definition, there is one element that you could use for that, but I don't think, which is, I don't know, there's one element here. It's not I don't know if it's the mapping or it's the definition thing. That's not helpful. Yeah, I think this is the one. No, sorry, it's not the one. I'm looking at element definition. Each element definition can be one of these. I think one of these can be a link to a logical model element. Yeah, this no, this is the formal definition in Markdown. I don't know. There is. I remember that there is a way to do that. So you can map things. You cannot link it as saying this model is from this or this profile is from this model. You would have to do some sort of mapping between those, and then you could have some magic to say, does my profile conform to the logical model, which would be awesome, I think, but that magic is not yet there. So if you're good with typing code, we would appreciate if you let us know, because then it would be a nice thing to do together. I hope that answers the question as good as I can.
All right, next one. Can you explain the difference between changing 0.1 to 1.1 and or MS? And there's been a chatter about this, so folks jump in if. Yeah,
indeed. So there's the whole cardinality section. What 0 to 1 means you can have 0 or 1, or 0 or 1 elements. 0 to star is you can have 0 or many repetitions of this one. So it's both optional. 1 to 1 is mandatory, but only one, and 1 to many or 1 to star is 1 star is 1 to many. So it's at least one, but might be more. And in FHIR, the only important thing to know is that if something is 0 to many, you can make it 1 to 1 or 1 to many. If something is already 1 to 1, you cannot make it 0 to 1. If it's mandatory in your base profile, you cannot make it optional on your top profile. And that's why I said before that if you're on a lower level, you might want to be more liberal with the data that you accept, because if you are too strict, then the other layers, they cannot become more flexible than you are. So you have to keep that in mind. More? Any other questions?
The last of the questions I have, and that actually brings us to time. So I will just say thank you everyone for joining. If you have more questions, we have a fireside chat coming up on August 20th. These are really informal sessions. If you come and ask questions to Jose, so it's happening in a few weeks. The slides and the recording for this session will be posted on our website a little later this week. So if you've missed anything, please come back and capture that. And then we are in the process of finalizing our next FHIR webinar, so please check our website for that. But there'll be one coming up later in the month as well, or later in August. So thank you very much, everyone.